I'm really happy that you decided to join us to learn a bit about Docker. And with me, you can see Andrew Pruski. He is a Microsoft Data Platform MVP, Docker Captain, a VMware vExpert. He also helps organize a lot of conferences. He's passionate about all things related to databases, Kubernetes, and containers, sharing his expertise by speaking at events across the globe. And he is from Wales. So, a huge round of applause, and I hope you will enjoy learning about Docker.
Thank you very much. Good morning, everyone, and welcome to this session, a deep dive into Docker. Just another quick recap about myself. My name is Andrew Pruski. I'm a Principal Field Solutions Architect at Pure Storage, Microsoft Data Platform MVP, Docker Captain, VMware vExpert, Redgate Ambassador, all-round basic database nerd. I'm originally from Swansea in Wales, but I've been living in Dublin, Ireland for, I think it's 12 years now. So if you're going, what on earth is this guy's accent all about? That would be why. My contact details are on the slide there, at dbafromthecold.com, on Blue Sky. We don't talk about the other social media platform anymore. dbafromthecold@gmail.com, my email address. So if you have any questions after today, please feel free to reach out. Always willing to talk about this stuff. My blog, dbafromthecold.com, posted multiple articles about running things like SQL Server in Kubernetes, containers. It's basically anything I find interesting. You're more than welcome to check that out. But finally, my GitHub account. All the slides and the code from the demos we'll be doing today, because this is a very demo-heavy session, are available in a GitHub repo, and I will post an exact link to that repo at the end of the session. So, on to the session. What are we going to be doing today? Well, we're going to be diving into the Docker platform to give you a little deeper knowledge of how things actually work. So we'll be talking about things like container isolation. How does container isolation actually work? We say containers are an isolated environment, but what does that actually mean? Then we'll have a look at some networking for Docker. How does networking work? And there are some advantages over just using the defaults that we'll dive into. And then for us database people, we got any database people in? They didn't let them out. Great. Okay, so we got some at the back. Yay. So probably the most important thing when it comes to working with containers and databases, stateful applications in general, is how do we persist our data from one container to another in Docker? Then we'll talk about building some custom images, because we generally don't want to rely just on images from the Docker Hub or the Microsoft Container Repo. If you just pull down images willy-nilly, you'll probably end up mining crypto. So we'll have a look at building our own Docker images. Then we'll have a look at Docker Compose and then round off by talking about some high availability for our Docker containers. But first things first, isolation. And the first thing I want to mention is there is no spoon. There is no such thing as a container. They aren't a thing. They don't exist. Now, it gets a little bit confusing because if you look in Docker and say Docker container ls, it'll show you a load of containers. But there aren't actually a thing. All they are is processes running on a host. And they are isolated from their environment, as it says here from the Docker website, to ensure that it works the same manner regardless of where it's deployed, staging, pre-production, production, QA. But how does isolation for containers actually work? Because if they're just running processes running on a host, how are they isolated? Well, they are isolated by three main constructs in Linux. The first one being control groups. So when we say, hey, I'm going to limit this container's memory, limit this container's CPU to negate the, say, noisy neighbor factor. Things like SQL Server, bless for my sins, I was a SQL Server DBA for 15 years. Will take every single little bit of CPU and memory on a host if you let it. So that's why we put limits on our containers. But what's actually happening in the background when we put those limits on is control groups are created that actually enforce those limits for things like CPU memory. And those are the ones we are most interested in when we're working with containers. So if control groups control what a container can use, namespaces control what a container can see. And they used to control a whole bunch of stuff. There's a load of them. Things like mount, separating the file system mounts. So each container gets its own separate file system. The UTS namespace, the Unix time-sharing system namespace, which sounds a little bit scary, but all it really does is isolate host name and domain name. IPC namespace, inter-process communication namespace, which isolates inter-process communications, things like message queues, semaphores, and shared memory. Then we have, let's pick another one, the network namespace. Isolates network resources. Processes running in a network namespace get their own IP address, network interfaces, routing tables, firewall rules. So they control what a container can see. Control groups contain what a container can use, and the final one is the file system. Containers do not have access to the entire host's file system. They can only see a subset of it because their root is changed upon startup. So they only see a section of the actual host file system. We don't want our containers to see the entire host file system. That would be an absolute disaster. So changing the root only gives them access to a subset of that file system. So we have control groups, controlling what a container can use, namespaces, controlling what a container can see, and changing the root of the container to limit the file system. Now, I said this is going to be a very demo-heavy session, so let's dive into the demos. Can everyone see the code at the back? Give me a thumbs up. Yay! Cool. Alrighty. So, I'm running locally with a VM in Hyper-V. Forgive me, I'm running on Windows. And I'm going to run a container. So I'm going to say docker container run -d, run a container in the background, publish some ports. So I'm going to pick port 15789 on the host to map to port 1433 within the container. Port 1433 is the default port SQL listens on. Now I'm using SQL Server images here as just a demo, but this works for Postgres, MySQL, Oracle, any other one, any normal containers as well. Stateless containers, I should say. But I'm going to map port 15789. I'm just plucking that out of thin air because I just need a port that's not in use on the host, mapping it in. And there I'm going to specify a memory limit of 2 gig. Accepting the end user license agreement, which we have to do every time we run a SQL Server container. I've talked to Microsoft about this. It's a legal thing. Setting an SA password so we can connect in, giving it a name, and then picking a container image. 3, 2, 1. Cool. Alrighty. Let's have a look and see if that container's up and running. And that's not very nice, so I'm going to clean that up a little bit and use a format, which I can totally type from memory and don't have to rely on code saved in files. So we have our container, we have it up and running. Let's grab that container ID. And now we can see the control groups created, and there's a whole bunch of them there, loads of them. But the ones we are actually interested in is CPU and memory. So let's grab those. Memory and CPU. So if I grab that now, if I grab that location, because everything in Linux is a file, divide it by 1024 a couple of times, and boom, we have our memory limit. So when we specified that memory flag in Docker container run, what actually happened was a control group was created in the background that enforces that memory limit. Let's have a look at the CPU. We didn't specify a flag for CPU, so we get -1. It's unlimited. This container can take all the CPU on the host if it wants to. We don't want that to happen, so let's limit it to 2. Excellent. Okay, we can do this on the fly. And now, if we check it out in the background, okay, it's 200,000 cycles, it's essentially 2 CPUs. We've enforced that limit. So all that's happening in the background when we put limits on our containers is these control groups are created to actually enforce those limits. Okay, so that's the control groups. Let's have a look at namespaces. Oh, let's grep that. And there we go. We've got mount, UTS, IPC. I didn't mention PID, process ID. Processes in a PID namespace can only see their own processes. We want this to happen. We don't want them to be able to see all the processes running on the host. There is another one called the user namespace, which allows you to mount different users in a container to different users on the host. By default, this isn't enabled in Docker, and that can cause issues, and we'll see that in a second. But let's have a look at that UTS namespace. So, if you have a look at the host name, okay, naming stuff in tech is pretty difficult, so I've just named my host AP Andrew Pruski. I'm running Docker on it, so Docker, and this is the first one I built, so 01, AP Docker 01. If I now execute that same command within the container using Docker exec, I get a different host name, and it's just a container ID, because that process is in a UTS namespace. If you have a look at the processes running, and for SQL you always get 2 two top, PID1, PID9. One of them's a watcher process, one of them's the actual SQL Server process. PID1, PID9 map to user MS SQL. If you have a look at the processes on the host, different PIDs. They are in a PID namespace. They can only see their own processes. Now if I grab that PID, one thing to mention here, in the container the user's MS SQL, but on the host it's mapped to user 10,001. That's the ID of the MS SQL user. It's mapped directly to it. Of course, the user doesn't exist on the host. That's why we get the UID and not the username. But it's a one-to-one mapping. User namespaces are not enabled by default in Docker. But anyway, if we know all this, we can actually use different commands to jump into those namespaces. So if I jump in, I didn't grab the PID. And there we go. My command has changed. I've actually jumped into that namespace. Do a clear, check the host name, and check our processes. There we go. I'm in that namespace. All that's happening in the background is Docker is creating these constructs, control groups, namespaces, to enforce that container isolation. One of the really cool things is that if we know this, do we need Docker to spin up containers? No, of course we don't. If you go and check out the GitHub repo that I'm going to link to at the end, Liz Rice, I've got a YouTube video there for a session by someone called Liz Rice, who actually builds a container out of Go code in 70 lines of Go code using control groups, namespaces, and changing the root. It's really cool. Go ahead and check it out. Anyway, let's jump out of that. Let's spin up another container, and this time I'm using a custom image, and what this is doing is running SQL Server as root. And if I grab the processes on the host, we can see that second process there is running as root. Root is mapped to root. The user namespace is not enabled by default, and this is why Microsoft changed their container images from 2017 to 2019 to run as the MS SQL user and not the root user. Because if someone gets into that container, breaks out of that container, they then have root access to your host. Not great. Okay, so let's go and let's create a database. Let's just create MS SQL CLI, connect it in, create database. Excellent stuff. And there are my files within the container. They live at var opt MS SQL data, or that's where the container thinks they live. If we try and do that on the host itself, ls var opt SQL data, doesn't exist. That container has its roots changed upon startup. So it thinks all its files are at var opt MS SQL data, but in fact, I've lost my connection. Docker inspect. That's not what I want, Copilot. Go away. Let's have a look, shall we? Merge directory. If we come up here, there we go. They're actually living here. So if I grab that and slap it here, there's my files actually on the host. I was worried for a second there. Okay, cool. But that's where they actually live, because the container's root has been changed and it can only see a subset of the host file system. So by those three constructs that we can see in action when we spin up a container, that is how container isolation is achieved. Control groups controlling what the container can use, namespaces controlling what the container can see, and then changing the root as well. Okay, let's jump back into the slides. So the next one, let's get rid of that. Networking. Okay, when you go on a Docker host and have a look at the default networks, you say Docker network ls, you will see 3 networks by default. None? Okay, we're doing exactly what it says on the tin here. No networking whatsoever. Really useful for highly isolated environments. You just want to remote into the container, do a load of work, and then blow it away. Host, effectively remove the partition between the host networking stack and the container's networking stack, aka let the container use the host networking stack. And then bridge. This is the default network that we use when we spin up a container and we don't specify a network. You can see it as the Docker 0 network if you do IPA on your host. Supports port mapping. Kind of useful. We saw this in the first demo where we mapped 15789 to 1433 within the container. kind of useful because typically we'll spin up more than one container on a host, and if they're all trying to listen on a default port of the app, we're not going to be able to do it. But the key thing here is that containers on the default bridge network only communicate by IP address, their internal IP address. So you can get them talking to each other, say if you have an app container or a database container, or if you're like me and you're testing things like Postgres replication, SQL Server availability groups, you need two containers talking to each other. You can only do that via IP address. So we kind of want to spin up something different, maybe a user-defined network. We have multiple drivers here. We have things like, we have the three defaults I've already talked about, host, bridge, none. There's Mac VLAN, where you can actually assign a MAC address to your container if you want to. IPVLAN gives you complete control over IPv4 and IPv6 addressing. There's also overlay, which is used for Docker Swarm connecting multiple Docker daemons together. And then, of course, there's user-defined bridge networks. Now, user-defined bridge networks have a couple of advantages over the default bridge network. One, containers can be connected to more than one of the networks. You can add a container and disconnect from multiple networks without having to restart the container, which you can't do with a bridge network. But the key one is that user-defined bridge networks support DNS resolution of container names to IP addresses. So you don't have to work out what IP address your container has if you want to get more than one talking to each other. So let's have a look at some networking. Get rid of that. Okay. Let's jump on and let's list our networks. So we've got bridge, host, and none, the defaults. If we inspect that bridge network, we can see here, no containers running. So let's go and spin up a couple of containers. Docker container run, accepting the end user license agreement, yada, yada, yada. Using a custom network, using a custom image here, basically just to install some network tools with a SQL Server image if I want to jump in and do things like pinging. Confirm the containers are running. We should have two. Yep, up 9 seconds. And now if we inspect that bridge network, we have our two containers with their IP addresses, 172.17.0.3 and .02. So if we grab those, excellent, and try and ping one from the other, so I'm execing into container 1, I'm going to try and ping container 2, it's not going to work. Default bridge network does not support DNS resolution from IP address to container name. So we can use the IP address, no problem, and that'll work. But we have to go in and we have to write that horrible long command to pass out that JSON and get at that IP address. So let's blow those away. Now, a little trick you can do is you can actually add in an IP address to the host file of a container, 17.03.02, and spin those up. Now, okay, there's a couple of problems with this. Firstly, you need to know what those IP addresses are going to be in advance. And if you spin up a lot of containers on your host up and down, it's not guaranteed. I'm quite happy to do it here because the container host is only ever running 1 or 2 containers and I know those IP addresses. But now, I can ping a container via container name. Okay, not great. Let's get rid of those. So let's go and let's just create a default bridge network. So if we say Docker create, and we're going to call it a name, SQL Server, not specifying any driver, so by default it will use the bridge driver. And there we go, nice and quick. Have a look at our networks, and then we now have our SQL Server bridge network. All right. So let's create 2 new containers on that custom host. And nice and easy, we just say Docker container run, specifying the network, publishing the ports, environment variables. Yeah. There we go. And now, if we go in, we can ping by name our containers from one from the other. Really, really handy when you're when I started working with containers, I was getting things like SQL Server availability groups up. Then the IP address is good, but what you really want is the container name for the actual instance that you're going to be targeting. You don't, because of course it can change So when you're scripting this out, you don't want to have to go off, grab the IP address, drop it into your scripts, redeploy. You can just have the container name in there. And it's all done via creating a custom bridge network. And that's because Docker has an internal DNS server, and you can see it there, 127.0.0.11. But for some reason, don't ask me why, the default bridge network can't use it. We have to use these user-defined bridge networks. Excellent stuff. Okay. Where did my... I know it's done. Come here. I love Windows. I love Windows. I love Windows. All right. Okay, so probably the most, as I said, important topic for us database folks. Very glad to see you here. I'm glad they let you out. Is persisting our data from one container to another. I remember when I first started working with containers and Kubernetes, and I spun up a container, did a load of work, blew the container away, and I went, actually, I need to get that data back. How do I get that data back? Ha 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 ha. That container was gone. There is no way of getting that data back. So we need options for persisting our data. But before we actually talk about the options for persisting our data, I just want to mention one thing about working with containers, Kubernetes, Docker Swarm, all this. I am a, by trade, SQL Server DBA. Up until the containers started coming out, I was only working with, say, virtual machines or physical machines, with my SQL instances running on them. And I'm used to looking after my VMs, my physical machines, my instances of SQL. I'm used to patching them, whispering them to them, stroking them, whispering sweet nothings, It's the cattle versus pets things that containers brought here. Do we care about the compute? Really? No, we don't care about the compute. What we care about is the data. As long as something can access that data, we don't care about what it actually is. It could be anything. Physical machine, virtual machine, container, whatever. And that is what containers has brought. You don't fix a container. If there's something wrong with your container, you bye Shirley, gone. Pets versus cattle. It's a really cool way of thinking, and it really changed my mindset of how to working with SQL Server. I talk about disaster recovery a lot, and I work for a storage company. We have replication technologies. We replicate data up to the cloud for some of our customers. Do we want instances running there the entire time? Probably not. So what if we could spin up a custom image of SQL Server on demand to that replicated data in the cloud, instead of having VMs running all the time? Some really cool stuff like that. Anyway, I digress. Let's talk about the options we have for persisting our data. The first one, bind mounts, mounting volumes from the host. I don't like bind mounts. They are the antithesis of actually working with containers, because what you are doing is putting a dependency on the file system of the host to that container. Containers are supposed to be able to run the same way anywhere. But if you deploy a container that's relying on a bind mount, that bind mount has to be present on every single host you run on. Don't like it. Now, I see why people do this, because, hey, I had a customer said that I've got a 290 terabyte database and I want to mount it into a container. I was like, let's roll that statement back a few times, shall we? If you are running really, really large databases, containers may permanently not be the ideal solution. Now, that's why people use bind mounts, mounting from the host. Then there's data volume containers. Now, these are a bit weird. What you do is you create, not run, a container. You then add a load of volumes to that container when you create it. And in the background, Docker creates what's known as anonymous volumes. And then when you come to spin up, say, your stateful app, you don't individually mount your volumes. You just say volumes from your data volume container, and it automatically mounts them in. Really, really handy. I've seen it used very occasionally for when you have a lot of volumes that you want to mount in. But to be honest, things like Docker Compose make that moot point anyway. But it can be done. But the recommended way of persisting your data from one container to another is what we call named volumes. And again, exactly what it says on the tin. It is a volume with a name. Let's have a look at persisting our data for SQL Server. Bear with me. From one container to another. Alrighty. How am I doing for time? 20 minutes. Cool. Loads of time. Right, let's create 2 named volumes. We're going to call them MS SQL System for our system databases. SQL Server has 15 minutes. Oh, right. Okay, thank you. Right, so we have 1 named volume for MS SQL System and 1 volume for our user databases where we actually create our databases. Confirm our volumes. Cool, there they are. They are 2 volumes with names. Yeah, okay. So let's create a database. Well, let's roll that back a bit. Let's not get ahead of ourselves, Andrew. Getting all excited. Let's go and create a container. We're going to say Docker container run, mounting a volume at var opt MS SQL, mounting a volume at var opt SQL Server, setting some environment variables for default data paths and default log paths, setting a container name and the image. Nice and quick. By the way, when I first saw SQL Server spun up in a container in less than a second, it blew my mind. I'm just like, hang on a second. I'm used to sitting there waiting for SQL Server to chug through its install process and going, it'll be finished at any point now, I swear. But having the ability to spin up an instance of SQL that quickly. Okay, there we go. Now, one thing I do have to do here is SQL runs as our MS SQL user within the container. It will not have access to that location I've just mounted, so I have to change permissions. And now I can create my database. Excellent stuff. Let's have a look. Let's see where it is. Hopefully it's there. Test database, 2 even. And check the file system. There they are, var opt MS SQL test database, MDF, mass data file, LDF log file. And we can see them in the container as well. Cool. All right, there's no messing around here. Something's gone wrong. I'm going to blow that container away. Confirm that container is gone. Excellent stuff. But we still have our volumes. This is the key thing with containers. The compute now is separate from the data. Its life cycle is completely independent. So we can blow the compute away, spin it up, blow it away, spin it up, but we still have our data files separately. So I can spin up another container. Boom. Confirm that container is running. SQL takes about 9 seconds. I know we have to sit here and wait to come up within a container. And there we are. We have our database. So we have persisted our data from one container to another using named volumes. Excellent stuff. And let's blow all that away. Okie dokie. So custom images. So Microsoft release images for SQL Server and they release them to the Microsoft Container Registry, which we can pull down and use no problem. However, I would always recommend you build your own image and share them in your own container registry. Now, installing SQL Server in a container image is nice and simple. It's literally the same process as installing on Linux. Why? Because containers are just processes running on a host. That's all they are. But I would highly recommend you don't rely on images from a Docker Hub or Microsoft Container Registry or anywhere they publish releases. Build your own images because you get control over things like keeping them up to date, security patching, customization. And we build our images via what's known as a file on a host that contains a bunch of instructions, known as a Docker file. And when we execute a command, Docker steps through each one of those commands in a Docker file, building us our custom images. That gives us the ability to do things, grant permissions to file directories, add databases to SQL Server. And so here is an example. We have building from, I know, said don't rely on the images from the MCR, but just bear with me, it's a simple demo. We're going to start off with the MCR. We're going to use a SQL Server 2019 CU5 based on Ubuntu 18.04. I know it's a little bit out of date. We're going to switch to the root user, make some directories, grant permissions to those directories, switch back to the SQL user, and then spin up SQL Server. Very simple Docker file, but it gets us over the problem we just had where we had to spin up a container, then grant permissions, and then we could create our databases. So let's go ahead and let's build a custom image. Okay. So, I'm going to navigate to where my files are, and we have the Docker file. Exactly the same as it was on the slides. So we're going to jump out of that. I can just say Docker, build me an image, -t, tag it with a name. We're going to call it, I don't know, custom image 1, and then dot. Look in the current location for a file called Docker file. And we can see, I've got a warning there about the legacy thing, but we can see it stepping through each one of the commands in our Docker file and building us our custom image. And if we go ahead now and have a look, there's our custom image. Haha. Anyone here work with Docker files quite a lot? An image of 1.51 gig is gigantic. It is SQL Server images are pretty big. However, I will say, for me, it's not that big, because when we first started, we were working with SQL in Docker containers. We were working with Windows containers, and the Windows container images were once, I think they were anywhere between 10 and 15 gigs. Absolute nightmare to work with. Although you are talking to a man who once built a SQL Server 2014 image that was 22 gigs, and then pushed it to the Docker Hub and got a very angry email about it. Right, anyway. Okay, so let's create a load of volumes. There we go. Local driver, just running locally. We've got one for our backups, our data, our log, our system, but now I can run a container from a custom image. Docker container run, publish, mapping our name volumes to locations within our container, setting a load of environment variables, default data directory, log directory to those locations that are supported by our name volumes, setting an SA password, giving a container name, and a custom image. Okay, check that container's running. Check the permissions on those locations, and we can see that the MS SQL user now has access to it because we set that within our Docker file, which means we can now go and just create a database. Confirm that database is there. Excellent stuff. And to have a look at those files. So we've got them on the data and the log files. Cool. Now, if I want to blow that away, I'm very conscious of time here. Container is gone. Let's spin up another container. Exactly the same. Can check that it's running. And if we give it about 9 seconds, I know we have to wait. We can check that if our database is there. Excellent stuff. Okay, so by using a Docker file, we've got around that issue where we had to go in and set permissions to any custom directories. Nice and simple. Of course, that is a very, very simple Docker file, but if we have a look here and have a quick look at a larger Docker file, go away. So, if I was actually going to build a SQL Server container image, what I would do is start off with, say, from Ubuntu, from a base image through Ubuntu. It'd be 2204 now, 2404 probably. No, it's not supported, 2204. Basically, you have a label in there, maintainer, basically who to blame when things go wrong. Add in the SQL user, and then running through the install of SQL. Installing the dependencies, adding GPG keys, adding a repository, installing SQL. We can install SQL Server tools if we wanted to, probably not. It's just SQL command if we wanted to go into the container and connect into SQL. Creating our directories, and then we could copy some database files in. Now, this is kind of an anti-pattern. You shouldn't really do this. Now, I say you can do this as long as they are schema-only files. Don't copy massive database files into your container images. It's a bad thing to do. But schema-only, yeah, okay. We can set some permissions on our directories, MS SQL var, setting the permissions even as we did before, attach DB script, setting some environment variables, and then starting SQL Server. Now this is a bit weird, bit of a quirk. We're running the attach DB script before starting SQL Server. Now the reason for that is what happens when we run that script is the script starts up and waits 20 seconds. And then attaches the database. The reason being is that a container always needs a process running. If we had it the other way around, started the SQL Server and then attached the database, the attached database script would become the main process, PID 1 in the container. It would start up, attach the database, stop the script, and then the container would shut down. So by switching it around this way, waiting 20 seconds, SQL starts up, becomes PID 1 in the container, the main running process, and then the database is attached and the container stays running. And I'm not going to tell you how long it took me to work that out. many, many times of why is my container stopped? Everything's fine. Okay, 5 minutes. Okie dokie. But anyway, that's our custom images. We've pretty much went to the bottom of that. So jump back into the slides. We've only got a little bit left. So Docker Compose. So way back in 2018, I went to DockerCon. I was speaking, but I wasn't a Docker captain at the time. And I went to the speaker meal and sort of ran up to a load of captains and went, hello, my name's Andrew, and I have questions. And when I talked about Docker Compose, I always thought it was for multi-container images. And I never used to use it because I was only ever really spinning up one SQL container at a time. I didn't think it was really anything pertinent to me. But one of the captains said, no, I use Compose for everything. And the reason being is look at this container run statement to get a SQL container up. Docker container run, publish, setting some environment variables, network, volumes, name, image. 15 lines of code. Am I really going to be typing that out every single time I want a container? Not really. Okay, yes, I could save it as a script and execute the script, but there has to be a better way. And that way is Compose. The ability, kind of like Kubernetes, to use a declarative method to spin up containers. We put everything we want in a YAML file and execute that YAML file instead of typing out all that nonsense. So, last demo, everything's gone well so far, I feel. How is it going to break now? So there's the container run statement. Let's have a look at Docker Compose. And we can just navigate to the location. We've got a whole bunch of files in here. We've got a Docker Compose file, a Docker file, which is the same as the one we saw in the previous demos, an environment variables file. Okay, I've got my MS SQL password in there. Not great if I'm going to push this up to a repo, but we could have that .env file say in a git ignore file and not push it up. And we've got our Compose YAML file, where everything is a service, specify the Docker file that we're going to build, some ports, our environment variables, and our volumes. So let's go ahead and let's just spin that up. How easy is this? Docker Compose up-d. And that's going to create a network, our volumes, build us an image, and then spin up our container. And we can see that now. We now have a custom bridge network, Compose default, a load of name volumes, images, and containers. Nice and simple. So I would 100% recommend that if you are working with Docker, no more Docker container run statements. Do everything in Compose. You can have it in the YAML files. They can be versioned. You can push them to GitHub repos. You can source control them, work with them. It makes things a lot easier. It covers everything that we've talked about today. Networking, networking, volumes, building your own custom images. Nice and simple, one-line command. And again, of course, to spin it down, Docker Compose down. And of course, it'll delete your container, your network, but your volumes won't be deleted unless you specify a -v flag, because it keeps, again, the life cycle of your volumes separate from your compute. Alrighty, so we've only got a couple of minutes left, so let's talk about some high availability. So there is Docker Swarm. Now, when I first started working with containers, I was working in a company in Dublin, and my QA department came to me and said, look, we're having a real problem here. Every month we refresh our VMs and we rebuild all of them. There's about 40 of them. And we reinstall SQL each time. And it's taking anywhere between 45, 60 minutes per VM, purely because of the host they were running on. They were Citrix Xen servers, which were old back then. And of course, this process wasn't exactly reliable either. It did fail, and then they're left trailing through error logs, trying to work out what went wrong, redeploying. So we re-architected everything, got rid of the local SQL installs, and had containers spinning up on a host. And after we built all this, so what would happen is you'd spin up the VM, a script would pop off to the container host, and it would spin up a container for that VM. So 45 to 60 minutes it used to be. We got it down, fully deployed with this custom SQL image with databases ready to go and have their data pumped into them. 2 minutes. Huge saving. It actually saved us about a month's worth of dev time per year, we worked it out as. So that's how I got involved. However, one day I came into work and that host was down. All the containers were down. Nobody could do any work. And I was the most popular person in that office until I got everything back up and running and people could do their work. I didn't have any high availability for that host. What I needed was something simple, nice and easy, just to provide some basic high availability. And that's what Docker Swarm gives you. A swarm of Docker engines that requires no additional orchestration software. Gives you nice built-in resilience, and it uses a declarative model just like Compose. Everything is a service. So if you need something simple and you need high availability for your Docker containers, definitely check out Docker Swarm. It is definitely still a thing. However, let's talk about the elephant in the room when we talk about container orchestration and high availability, and that, of course, is Kubernetes. Kubernetes definitely did win the container wars, or the orchestration wars, I should say, between them. But Docker Swarm does have a simpler setup, obviously tighter Docker integration. It's nice and lightweight, but of course it has a limited ecosystem, lower community adoption, weaker multi-cloud hybrid support, purely for the fact that everyone's and their uncles is talking about Kubernetes at the moment. Huge community out there, really loads of community plugins being built. It's endlessly customizable, and it provides better HA so if you're looking at real production high availability, definitely look at Kubernetes over Docker Swarm. But if you were like me in that situation and you just needed something simple and easy, that's where Docker Swarm comes in. How am I doing for time? I'm over 0. Right. Okay, thank you so much. This is the link to the repo that contains all the code and the slides that we've been talking about today. Have a good rest of the day. Thank you.
So thank you, Andrew. A really great talk, but there are questions.
Oh, yes.
There are a lot of questions, but we will start with can a bind mount handle multiple writes?
Yes. Depending, if they're talking about multiple containers talking down to the same bind mount, yes. However, for SQL Server databases, no, because SQL will lock the database files. And that's probably true for most database systems, purely for the fact that it's to prevent that split brain functionality.
Okay. So another one. Could you please explain again how creating custom bridge network allowed us to ping via namespace?
Custom bridge network will allows you to use the built-in Docker DNS server, whereas default network doesn't, and that's why it supports the DNS resolution from container name to IP address.
Okay, so another one. And this is also a question that I'm very interested in. Which plugin do you use in VS Code to run selected code in the terminal?
I don't. I have a custom shortcuts built that allows me to either select text or just run the text that's on the custom line by hitting Control and semicolon. Actually, if you check out my blog, I've got the plugin for you there.
Okay, thank you.
It's not a plugin, sorry. I've got the script there.
Okay. What are the advantages of using containers with named volumes rather than a database on virtual machine on-premise data storage?
Well, it's the flexibility that containers gives you. So if you are running, say, a VM or a physical machine, that's pretty much, you've built that, it's running, it's there. Containers give you the ability to spin up quickly, do a load of work, blow it away. So ideal for things like CI/CD pipelines and whatnot. Building from custom images allows you to deploy a customized instance of SQL Server in seconds. You don't have to do any further configuration, so you're not running through the install process. So things like CI/CD, containers are perfect for that.
Of course. How can I back up my database with containers without using cloud storage in the production environment?
Oh, this is a great question. Pretty much because we get a little bit sidetracked when we start talking about Kubernetes and containers, because I'm the same thing. We start thinking about, I'll do volume snapshots, or I'll use this plugin or that plugin. It is just another platform to run your databases on. You should be running your backups as you would wherever, say if they were a physical machine, virtual machine, wherever. So for SQL Server, if you're running for a long time in a container, you're still taking your fulls, your diffs, your transaction logs, 100%. Don't get carried away with, I can do this snapshot or that snapshot or this, that, the other. You still need to roll through your DR strategy for that database.
And we are near the end, so don't worry. As Kubernetes is on the market, does it have sense to stick to Swarm?
Well, as I said, if you just need a simple environment that provides high availability, yeah, you can use Docker Swarm. But if you really do need all the customizability that Kubernetes gives you, or you are running, say, in a highly adaptive, fluid production environment where you need what Kubernetes gives you, you have to go with Kubernetes. It just did win the orchestration.
And the last one. What if I need to run my Docker container differently sometimes, like changing a CLI argument to the command in a Docker compose?
Blow the container away, redeploy. That's the best thing I can say. If you need to, you don't try and fix a container, you blow it away, spin up a new one.
Okay. So, anyone has a question from the audience? One quick one?
How to find your blog?
It's dbafromthecode.com.
So,
thank you. I have to run to the airport because my niece's communion is tomorrow morning, which I totally forgot about. So
huge round of applause.